in this class, that is lesson 14, parametric drafting, we have already learned about overview, constraint, geometrical constraint. And now here we learn about dimensional constraint, and also we have learned about how to manipulate the dimensions and how constraints, geometrical and dimensions can be applied to an object. So I will open the AutoCAD drawing. Now, as you have seen, geometrical dimensional constraint is here. Alignment, that is aligned, horizontal, vertical, angular, radius, diameter. These are the dimensions normally the object takes in the 2D. I will draw a line here, a horizontal line. Now I will remove this horizontal constraint for simplicity, and I will apply only dimension. Suppose I apply horizontal dimension constraint. It is applied like this. Horizontal. See, 1, 2. See, this is it. D1 equal to 296.6149. So this dimension we can modify. D1 equal to 200. See, it becomes 200. But you should remember, this is not the dimension. This is not a dimension. We have not dimensioned the drawing, but we have applied a constraint. Dimension the drawing is from this menu or from here. We click and this is dimensioning. See here, you cannot modify anything here. You can change the dimension of the dimension will remain the same. But if you modify this, see what is going to happen. Equal to 300. See, but this has not modified. If you want, you can move it up to here. So and see, this has become 300. So, and suppose we click on this or like this. Click, and there are two triangles on either side. It means that you can modify the dimension not by entering the value, just by dragging it like this. Okay. So I will do the other way. Suppose I can drag not vertically, I can drag horizontally. Suppose I drag it and capture this value. Now let us rotate, because we have not applied any geometrical constraint. The horizontal constraint what we applied, we have removed it. And now let us see what happens when we rotate. We can click here, say 30 degrees. Just see. The dimension, horizontal dimension remains the same. It is not changed. Only the length of the line has changed. Okay? Suppose we change it here. As usual, D1 equal to, let us say 100. So it becomes 100. Suppose we D1 equal to 200. It has become 200. So the line horizontal dimension is only changed, not the vertical dimension. Now, let us similarly up dimension, vertical dimension we will apply. Let us see what is going to happen. Like this, like this. Oh, we didn't take. On the line we have to Constraint cannot be applied, it conflicts the existing constraints. You cannot apply the vertical dimension. It is conflicting. Let us analyze this, what is happening here. Because it has already taken up this dimension, the vertical you cannot change. This inclination is kept constant. You cannot change the dimension. Or now we apply a vertical dimension. What we do is we erase this. We remove the dimension. Now we'll see whether we can apply the vertical dimension to this. Vertical. See, we have applied. Suppose we try to apply vertical dimension. Let us see what is going to happen. See, you can't. Okay, vertical dimension you can't apply. Horizontal dimension you can't apply. I will erase this. So we know how to apply vertical and horizontal dimension. Now we will take up an inclined line like this and let us apply alignment dimension. See, this is aligned dimension. We will apply this. Like this, one click, another click, press right hand mouse, click, and we got our return mouse, we can see. So this is the, here we have our alignment dimension we have applied here. Okay, the distance remains 366 point, etc. 57 or something like that. We can change it. The value, exact value we will give. Let us see what is going to happen. V1 equal to 350. It is a 350. Now let us rotate this. Rotate, we can use a symbol here. See, 350, the total length remains the same. Wherever you go, the alignment, it remains the same. The length will not change. Suppose I move it horizontally, you bring it to vertical direction. Let us see. We will bring it to vertical direction. See, 20 degree. It is 90 degree. It is then it was slightly inclined, and it is now 90 degree. It remains the same. Okay. Now, we apply the alignment direction for a horizontal line. Let us see how it can be applied and what is going to happen if we apply alignment dimension. We have applied the line dimension. See, suppose we want to rotate this. See, the alignment, the length of the line remains the same. It is not changing because we have applied alignment dimension, so it remains the same. Earlier, when we saw horizontal direction, when we applied, the horizontal distance remains the same. The length of the line is increased because it has to maintain the horizontal dimension of the line. Here, the alignment is remains the same. Aligned direction, we have aligned and constraint, dimension constraint we have applied. Now, I will draw another one. I will remove this, and now I will apply horizontal dimension. like this, like this. And now I will apply geometrical dimension, geometrical constraints, so that one side coincident, I will apply it here, or instead of that, we will apply fix. This end will fix. This end is fixed now. Suppose we try to move. We try to increase the dimension. That is, by clicking on the dimension, you can get these two triangles by it moves here. Suppose you try to move here, it moves in the other direction because this end is fixed. We have applied a fixed constraint here, the fixed constraint. So it will not move in the opposite direction. I will erase this. Now, we will draw a triangle. What is going to happen? Let's see. Here, the points we have applied the geometrical dimensions. Geometrical constraints. This one, this geometrical constraint line is coincident. This is applied automatically because auto constraint is on. Now let us see how we can apply dimensional constraint. So I will apply aligned for this line. And I will apply alignment for this line. And I will also apply dimensional constraint to the other line, last line. See. Now, let us try to increase this. We can increase D2 equal to 600. Can we? No. D1 see, name already exists, so I will say D2 because D1 is there, so D2 you cannot modify it. We just modify the dimension. See, it has changed. Why it has rotated? We will see. We will analyze why it has rotated. See, what has happened is these are all fixed points. Geometrical constraints have been applied here. 1, 2, 3. But this line length is also fixed. This line length is also fixed. You are going to alter this line. So when you alter this line, its length is increased from 600 to 1000, and to keep the constraint, it has to rotate. Suppose I change this to some other value. $900. Change. Here also, the line, other two things remain the same. Suppose I drag this, the entire triangle I will drag. Let me see. Like this. This is the dimension. See. Dimension remains the same very well. Okay. Suppose I drag this line. So we will drag now. What is going to happen? Let us see. See, the entire triangle moves. See. Dimensions remain the same, but triangle either can move or rotate as a single object, like a single straight line. Okay. That is because these constraints should be same. this fixed constraint we have applied at this point should remain the same. It cannot change its position. Line N should always be in contact with the other line. This line should be in contact with this line to be in contact with this line to be in contact with this. So when we move one of these points, then as you move it, along with it, the contact also remains, and it will also move, and the entire triangle move. It can rotate also as such. Okay. Dimension we can change. I have already told you. So click here. You can change dimension. See, dimensions remain the same. This dimension changed because this is only the arrow mark. This triangular mark refers to this dimension. This has changed. Other two remain the same, and the shape has been changed because this point should be fixed all the time. So we'll erase this. So depending upon your requirement, you can manipulate by this menu. There are so many things. Depending upon what is the requirement, we can manipulate. Now we have studied dimension, alignment, horizontal, vertical. Now you see angular, radius, and diameters. Now let us see the angular. I will draw a line. I will draw another line. This is fixed constraint is applied. Let it be there. This is because automatically applied because of auto constraint is on. So I will show you. See, these are all on, so it is applied automatically. Even otherwise also, some of the constraints, all these constraints will be automatically applied once you click on auto constraint. Okay? Now here, how to apply the angular dimension is very simple. As earlier, we had to select the two lines, angular. Select this line, select this line. This is what. Angular. Now angle is 45 degrees. You want to change 55, change. So since we started from here, this line has not changed, and this line is only have swung. Okay. Suppose I want to make it minus 55. What is going to happen? Whether it takes the value, let's see. See, it has taken. But this line becomes fixed. This is how we can apply. Now, we have seen this line is fixed. Suppose I want to make this line fixed. What we can do is parameter. You go, you apply geometrical constraint. Which one you can apply? We can apply fix this end. So this point and this point on the line is fixed. So the line is fixed. Now let us see what is going to happen if we change the angle. This line has changed. Okay. Suppose we fix the other end also here. Now what is going to happen? Let us see. Yes, it has taken the angle. Only thing what happened is the line length has been changed. That's what I noticed. Let us see once again. See. This point fixed, this point is also fixed. It only swung, the length also get changed because this point is fixed. So this point is also fixed with this, so it has to See, suppose I will change it once again. Say I want to make it 45. See, this point remains the same, this length have been changed. See. So this is how we can manipulate. So depending upon, we have fixed here, we have fixed here, we have fixed here. So angle is changing, length gets changed. It is as good as drawing a line from here to here. And this is a triangle. Here, this point is fixed, this point is fixed, this point is fixed. Before drawing this line also, it was fixed. So it is as good as changing the angle of a triangle where two sides angle between them, two sides angle between them is known, then naturally the length will get changed, affected. Because this point should be fixed in position, so it has to be, the point can be fixed, but it can move, points can move from that position. The point cannot move from the position, it has to be there only. And I will just show you that by drawing a circle, how it remains the same in the position. So this is fixed, this is fixed. I will draw a small circle here. So I will delete this. I don't want this to be applied. I will apply. I will delete this also. Let us see what is going to happen here. See, the positions remain the same. The position, because here the constraint is, it is not fixed, it is coincident. Only these points are fixed, but this is a coincident, but the line should have contact. So only this point is fixed, this indicated by this, and this point is fixed, indicated by this, and this is just a coincident. Suppose we apply a fixed position for the other point. The coincident point also we will apply a fixed constraint. Let us see what is going to happen. See, the constraint cannot be applied, it conflicts the existing constraint over constraint. The geometry will be over constraint, it is more than the required. It's a balanced constraint, over constraint, and you cannot do any such other performance at all. So it has been, we can remove this, possibly we can remove this and we can apply. See, it's applied. Now what is going to happen? Because the connection is not there, it is fixed, but this line and this line is not having coincident. So I can modify this, what is going to happen. See, it has changed. Angle is maintained, but this line link is broken here because there is no coincident constraint. So the line is broken and is no longer the symmetry. The line length is this. It's up to this is only the angle shown. The length is remains same because this point is also we have fixed. This point also we have fixed. So this point is fixed, but this point is free to move, and hence the line is a little bit extended. Suppose I make a fixed constraint this end. It says it's not possible. So it will be over constraint. Erase these things. Now, angular we have applied. Now, what other things are there in the dimensional constraint? Let us see. Now, radius and diameter. How we can apply it? As you know, radius and diameter can be applied for the circle or arcs. Now let me draw a circle. So I want to apply radius constraint. So radius. Click this. Radius is mentioned. You can change radius. Suppose I make it 500. The radius is increased. Okay. So you can change to any dimensions. 600. Anything. Say 300. Okay. Now let us see whether we can apply the diameter constraint for the same drawing. Diameter. Click on this. But it shows the same diameter. 600. That is double the radius. It gives the value double the radius. Suppose I change this to 800. It cannot be applied because constraint already exists. So there is no point in applying the diameter constraint to this because radius is there and that is sufficient. Now suppose we draw a line, a curve, let us say, a curve for the circle like this. Here automatically the coincident constraint have been applied. This is applied here, and that is this chord will always maintain the contacts with the circle, always on the periphery of the circle. There will be 2 points. Suppose we change this radius to 600. Yes, it has to maintain the same contact. So line is increased, length of the line is increased. Suppose I apply a dimension to this, dimension constraint to this line, let us say, aligned. Dimension constraint, aligned. This should mean 955. Suppose I change the value here. Can we 800? Yes. Only thing is the chord length remains the same. So its distance from the center, the perpendicular distance from the center to this line is increased because the diameter has been increased. There is a limit. It can become maximum diameter, but it cannot be more than that. This length can be equal to 800. The circle can be of diameter 955.78. Up to that, this can be applied. Suppose I apply. I will do one thing. Let me see what is going to happen if I make this change. So it has become. Now suppose I apply this 450 exactly. It became the diameter because contact should be maintained. Suppose I want to change the radius to say less than that. What's going to happen? Let us see. It says a dependent expression cannot be evaluated. That means this radius, what chord, which is now become a diameter, its length should be 900, but radius we want to reduce to 300. That means the diameter becomes 600, 900, 600. The chord length is more than the diameter circle, which is not possible. Hence, it gives a message that I will read the message. The message given was a dependent expression cannot be evaluated. That is, it becomes a dependent expression. It cannot be evaluated, and that is the you can't have that. Now we have learned. Similarly, we can apply the same thing for an arc. We can apply dimensional constraint to an arc. Say arc diameter, and if you want, we can increase. See, arc has become smaller. Okay. Suppose I join these two and a constraint is applied. It's a fixed constraint. Obviously, it will get changed. The length will get changed now. Suppose I make it 1200. It get changed. The length of the line will increase. Suppose I apply the constraint of align constraint to this line. So here what is going to happen? Let us see. Suppose I want to change this line, then diameter get changed. Suppose I diameter changes. Diameter is the center distance of the arc get changed because this is a arc. Its position will get changed from the center. Its radius diameter remains the same. Only its relative position is the chord position is get changed. Suppose I make it 300. Say it get changed, but the radius remains the same. This is how we can apply dimensional constraint, and we can apply things together also. We will do the next exercise. In the next class, a few examples we will do, and in little more we will explain you about the dimensional constraint. We have explained all these points. Angular also we applied. If you want, we'll apply another once or twice. The angle for an arc, how we can apply, let us see. If you want to apply angle, let us see how we can do it. Angular. See. Click on the arc, it gives the angle of the two ends. If you want to change it, you can change it to say 100. It is increased. Suppose I draw say another arc. I can draw another arc. I can join these two things. I can join the other two things. And suppose I want to make this concentric. This arc and this arc are both to be concentric. What we do is geometrical constraint. This is the thing we consider. See, and become concentric. Okay. Let us once again apply that. Suppose there is a coincident constraint exists. Earlier it was not there. Let us see what is going to happen. And this side also will make a coincident. Now let us see if we want to make concentric, what is going to happen. Select it as. So here this length maybe a little bit get changed, but now both of them become concentric. Okay. This is how we can manipulate the objects in a drawing using constraint, and we can with a single simple drawing, we can make it change to any other types by adding and removing constraints and change the shape of the drawing. We learn a little more about these things in the next class. I will end it now.